Hey everyone. Today's example is going to be force-based and Newton's second law based. So here we have an 850 kilogram car accelerating at a rate of 2.4 meters per second squared to the right. So let's start with that. Our M is 850 kgs and our acceleration is 2.4 meters per second squared. And here it says it experiences an overall frictional force of 1500 newtons. So we know that our force of friction equals 1500 newtons. And that's going to be going backwards. So we don't have to put a negative or a positive to it yet, but we'll make sure we account for its direction later on. And then we're looking for the engine force. So the FE is a question mark. So let's draw our free body diagram first. As always with forces, we have our 850 kilogram vehicle with an engine force going to the right, a frictional force going behind us, and don't forget we have our normal force from the ground and our gravitational force coming down. So since we know the car is accelerating on a horizontal road, we know that the F gravity and the F normal are going to be equal. Just to show that, we can draw it out. So our FG of the car, actually, let's start with the F net in the Y direction, which this will equal, we have our F normal going positive and our force of gravity going negative. So that's based on our coordinate system here, where we call this Y plus, X plus, and if we were to do these directions, that would be X minus and Y minus. And that's based on if our object was right in the middle here. So our FG, we know how to solve that already. So FG equals, that is MA or MG, since your acceleration due to gravity is 9.8. So our FG equals 850 kilograms times negative 9.8 meters per second squared, and that gives the gravitational force of negative 8,330 newtons. And since we know that our F net Y is equal to 0, since the car is not moving up or down, it's moving left and right, that means our Fn has to be equal and opposite to the gravity. Cool. So that doesn't really help us with the question. That was just more for knowledge and understanding. And now let's find the engine force. So we can divide that, the F net in the X direction, which would equal the engine force minus the frictional force. But we can't do the same assumption we did for the Y. We can't say that F net X equals 0 due to the fact that it is accelerating 2.4 meters per second to the right. So we have an acceleration in the X direction, meaning our F net X equals MA, A being 2.4, and our M being 850. So our F net X is actually equal to, that is 2,040 newtons, and we can write the direction to the right. So now we know our FF. This here is equal to 1500 newtons based on the question. So we can solve for our engine force. So we have 2040 newtons for the F net X. We have our engine force and we have our frictional force. So I just subbed in their values there. So if we rearrange, that would mean our engine force equals 3,540 newtons. So this would be the engine force required to make the 850 kilogram car accelerate at 2.4 meters per second to the right, while experiencing an overall friction force of 1,500 newtons. This is the force from the engine we would require. All right.